In 1963, Bell System came out with a tremendous innovation of dual-tone multi-frequency signaling, also known as a DTMF or touch tone. At the time, this was a phenomenal innovation because it was an improvement over existing signaling patterns, such as loop disconnect, that rotary phones used, because that signaling pattern was not able to travel long distances, and this meant that in order to make a long-distance phone call, you needed to have an operator manually connect that. With the introduction of DTMF keypads, like the one pictured here on the screen, all of a sudden now the signaling could travel a longer distance. You could automate that process, and it scaled the phone network. Of course, today, we live in a world of digital transformation, where digital technologies are disrupting and replacing analog technologies. In fact, take, for example, my iPhone, right? It's nothing at all like this keypad. I mean, it's a digital technology. It's completely different, has zero similarities. Or does it? If you look at the phone app on my iPhone, it's actually almost exactly identical to the 1963 keypad. In fact, making a phone call today is pretty similar to what it was like in the 60s, and it even uses DTMF signaling. And why is this the case? That often when we have new technologies and they emerge, it's almost a cliche or a trope that we start to implement those new technologies using the same old pattern instead of being new and innovative. Today, I hope to talk to you about digital transformation, and in particular about cloud-native transformation. At GitLab, we are one of the unicorns that Siddhartha talked about. We have a focus on software development and delivery, and so this is the bent that I want to talk to you about cloud-native transformation. Tell you a little bit about why it's important, what the technologies are that make up cloud-native, and even how some of organizations are driving successful cloud-native transformation. And the hope is that when you exit today, you have a bit of tools or key concepts that you can take to, instead of implementing the same old thing with new technologies, that you can implement something new and innovative and reap the rewards of that. To talk about this, doing things the same old way, we'll look at the world of software development. And of course, with software development, we have a familiar pattern of waterfall software development. I imagine that for many folks in the room, your software engineering organizations probably in some parts are still using waterfall. And you know the pain points of having that methodology. In fact, doing waterfall is really like delivering software like it's a hardware product. When you have a physical product to ship, it has to go through all of these various stages. And so when we went to go deliver software, we said, let's go through all of these stages in a waterfall fashion. But it ignores the unique properties of software. It doesn't take advantage of what you can do with software. And as we know, the pain points of waterfall are that it's a very long time from the time you develop that software to the time it's actually delivered to a customer. That feedback cycle is very long. And you may be aiming for a target, but by the time you actually get there, the market has shifted. So it's very hard to avoid disruption if you have these long waterfall software development cycles. Of course, the world changed, and then we have the Agile software development. And for many of you, your organizations are going through an Agile transformation. This is making smaller changes, shrinking the cycle so that software is developed faster and released quicker. And these small iterative changes allow us to reach the target faster and get feedback sooner so that as the market and the world shifts, we can adjust to that. But of course, as you know, if you're using Agile software development in your organization, there are pain points with Agile. Predominantly, if you are doing Agile development, your development team is delivering software very quickly, but then when they ship it over the fence to the operations team to actually deploy and operate that software, that can be a very long cycle. It can take 6 months. Maybe you deploy every 6 months, or you deploy every 6 weeks. But if your development teams, your software developers, are trying to ship software very quickly, and it doesn't get released for 6 months, it really defeats the purpose of trying to get that tight feedback cycle. So, of course, to address this pain point, the world changed, and we have Devops. And DevOps is really about having development teams and operations teams coming together, both culturally and technologically, to bridge that gap so that you're shipping and iterating software very quickly, but also so that you're automating your deployment processes. So those are also fast. So you move from 6 months to 6 weeks to every 6 days to 6 times or 6,000 times per day. It's maybe a little bit high. I've heard about 1,000 deployments per day. And the idea is when you are implementing DevOps and you can iterate very quickly, it then ties that software development lifecycle together. But as you know, if you are using DevOps in your organization, there is still yet another pain point. And this pain point is that your infrastructure, where you are going to run your software, you need to pre-provision it. So you need to determine what your load is to figure out, am I going to have very high load? Is my app all of a sudden going to become very popular with my user base tomorrow? I need to provision up to scale. The problem is if I estimate what that should be, then all of a sudden I'm paying a lot of money for a lot of infrastructure with very little load. Or worse, if I underestimate and I provision too little, then I get too much load and my software goes down. And we know that when the software goes down, the business is not moving forward, revenue is stalled. These are really big challenges. So again, the world is changing to address these pain points, and this is where cloud native comes in. Now, cloud native is really about developing new software in innovative ways and taking advantage of the unique properties of the cloud in order to deliver that software. So just like avoiding the trap of having a phone that doesn't change for half a century, cloud native is about adopting new technology. So yes, it's about using Agile. Yes, it's about DevOps. But it's also about implementing technologies like microservices and containers in order to take advantage of the unique properties of the cloud to deliver specific values. So looking at some of these is, why is it that companies go cloud native, or why do they go through a cloud native transformation? Well, it's really about agility with resiliency, or delivering better software faster at a lower cost. The cost savings are tremendous, as I've already started to allude to. When you move to cloud native and it's about these dynamic environments, no longer are you pre-provisioning, but you're dynamically scaling up and down based on load. This means if you get more load, you scale up. This means if you have reduced load, you scale down. So you're eliminating those waste of costs, but you're also running more stable so that you're eliminating the risk of going down. Of course, in addition to the cost savings of cloud native, there's also the speed advantages, that being able to deliver software faster and iterate, the true principles of Agile coming to fruition. This is why companies adopt this. And then stability, again, if you're releasing once every 6 months, that software release, there's a lot of risk when that goes out. A lot of things can go wrong. It keeps you up at night. However, if deployments become very boring, if everything is automated and things scale dynamically, then all of a sudden, releases are routine, your software runs more stable, and then adopting microservices spreads the load out so that your app is more stable. Let's dig into these just a little bit. One of the shifts in this world is moving from servers and virtual machines to containers and container orchestration technologies such as open source Kubernetes. At its heart, this is a cost savings, but also advantage. So if we look at the technology of containers, when you deploy an application on a bare metal server, you have the application within the server, but if you need to scale that, if you need multiple instances of that application, it means you need a server per application, which is very expensive, or running multiple applications in an environment where they can all interfere with each other, which isn't secure and has other problems where they can affect the performance. So servers don't work all that great, but thankfully we have virtualization. And virtualization allows us to segment out our applications within a virtual machine. This is a wonderful innovation. Things are more secure. We can now scale. We can fit multiple virtual machines on a single machine. But the problem is that virtual machines are very heavyweight, right? Each Each copy of that virtual machine contains a copy of the kernel, has the entire operating system. These are things that we really don't need within an application instance. So in order to gain scalability benefits, you have containers. Containers are a lightweight way of packaging your application software that only contains the application and the libraries and doesn't have overhead that VMs have, such as the kernel and operating system. So this means you can fit many more containers on the same amount of hardware, getting that cost savings of using less infrastructure or less cloud compute cost. In fact, Gartner says that today, and this report actually just came out in late February, there's about 30% of global organizations using containers today. But by 2022, the world is changing. More than 75% of global organizations will be running containerized applications in production. So containers are wonderful technology, but you can still run the risk of doing the same old thing. It reminds me of taco night at my house. I don't know if you have taco night, but my tacos are delicious. And let me say that we always make a ton. There's always some left over. And the tacos the next day, the deliciousness of those tacos depends on who picks up. I don't know if it's like this at your house. My wife does a great job. She puts the tomatoes in a container, the cheese in another container, everything's all separated, goes in the fridge, pull that out the next day, it's fresh and delicious. If I pick up the tacos, I have been known to, a time or two, just kind of shove everything in one spot and just put that in the fridge. Of course, you pull it out the next day, it's a bit of a soggy mess. And so in the same way, your business outcomes may be like my leftover outcomes if you're not separating into microservices. So containers and microservices go hand in hand. And this is really about separating concerns of your application. In a monolithic application architecture, this is what many of us deploy, whether we're deploying software applications consumed by our users or internally within our IT teams. The monolith is usually a single application, usually written in a single language, usually deployed as a single package. And what this means is as you try to scale and different teams want to work on different parts of the app, they have to coordinate with each other, they can have conflicts, and all of that overhead slows them down. It also means that there's a lot of risk. If one part of the app breaks, it breaks the whole app. And so monolithic architectures are risky, but breaking out into microservices can alleviate one of these pain points. It means that instead of one single application, you're deploying many applications as services that communicate to other parts of the app over API. And then development teams can own a service end to end. It means they can iterate and test very quickly, try new things out without the worry of breaking the rest of the app. This type of microservices architecture is what is fueling the innovation of cloud native. And of course, as I mentioned, containers and microservices go together, and this gives you the benefits of container orchestration. And so if you have just containers and you are trying to schedule those containers onto different pieces of infrastructure to run them, or what we'll call nodes, consider each a node a server, you need to fit those containers in. You are using far too many nodes to scale. However, with container orchestration like Kubernetes, it bin packs into the most efficient place possible, kind of like a Tetris game. So you can see the orchestration is far more efficient. This is where you're taking advantage of automation in order to have cost savings. So research done by Dimensional Research, they say 86% of IT leaders expect microservices to be the default architecture within 5 years. So this is the world changing to cloud native transformation. So this is some of the technologies that enable it. But how is it, what's the process that it looks like for an organization to go through a cloud native transformation? Well, they tend to implement some secret sauce of process change that I like to call the Steve Jobs wardrobe. So Steve Jobs wardrobe change agent is, if you think about it, Steve Jobs, he wore the same thing every day. And actually, one of my former friends and CEO of my last company, he actually adopted this model, wore the same outfit, opened up his closet, It was one big templated thing. I said, why do you like this? He says, it's very efficient. He wakes up in the morning, doesn't need to decide what to wear. But also, if you get a hole in your shirt, you just pull out another shirt. It's all part of a template. You don't have to worry about it matching. And I said, okay, this interchangeability reminds me a lot of DevOps. There's this concept of, in the old world, a server is a very bespoke thing where it has a certain operating system and certain packages, and you have to care about that server a lot. And if it goes down, it's very hard to replicate. However, if everything is just software defined, if you have infrastructure as software, then that can be templated out. And one server goes down, another server can come up and take its place. And that's what Cloud Native and Kubernetes runs in that model. But it's not just a technological process. It's also a people process and a way of structuring an organization. I'll show you what I'm talking about. This is what I call the Cloud Native enterprise platform pattern. And over again, as I've seen businesses of all sizes adopt Kubernetes, but in particular larger organizations, they are using this pattern between their development teams and their operations teams, and they're using templates. The idea here is the operations team builds a platform and builds a template for what that application is supposed to have. This way, as a development team, I don't need to understand all of the complicated technology. I have my operations team managing the platform for me, and I can get going right away. So you might have a template, and that application, I bring it in. It has a CI/CD DevOps pipeline that's already built out for me. It's basically ready to run and plug into my existing microservices architecture with that templated app. And that way, the service team only needs to add their business logic. So this type of architecture and interaction between teams really allows you to take the best parts of each team and leverage those skills, best parts of each organization, leverage those skills. And again, it allows those software developers to spend all of their time focusing on business logic and driving value versus doing undifferentiated lifting, this type of enterprise platform. In fact, there are hundreds of companies that have already begun their cloud native transformation. Some of them are in this room. These are folks of all sizes, but if you look at some of these, NAIC, New York Times, Nordstrom, Goldman Sachs, some of these are large, complicated enterprises, but they're adopting this new technology because it's allowing them to realize dramatic cost savings. It's allowing them to move faster and increase the pace of innovation. It's allowing them to run stably so they can sleep better at night. And so my hope is, as you've just taken a little nugget of this or seen what Cloud Native looks like, you think about Agile and DevOps and Cloud Native to implement these processes in your organization. So it really just leaves me with one last question, which is, when will you begin your Cloud Native transformation? Thank you. And we can catch up during our networking session as well.
What are some of the key lessons learned when companies go towards microservices?
Key lessons learned when shifting to microservices. That's a great question. So I would say in a nutshell, there are the benefits of the microservices, which I dug into, but of course didn't dig into the full-time, some of the pain points. So essentially there's a trade-off between simplicity and complexity and an inverse graph of the risk and innovation pace. So that's something to manage. I'll give you an example. So the idea is when you break apart a monolith, and that could be 5 services, that could be 500 microservices. Folks like Uber, I think, have 1,400 microservices if you think of an app like that. It's at that scale. And at that scale, it's very, very complicated. There are things like service discovery. How does my application even get to all of these other routes? And how do I manage all of that complexity? You need additional tooling to manage that. So what I've seen as a best practice is that folks do that gradually. There's a pattern called the Strangler Pattern. It's kind of based off of a vine that climbs up a tree. And you have the tree initially just has one vine, and then another vine comes, and eventually the vine takes over. and the vine is only the vine there and no tree. And that's the kind of idea with microservices. The key practice is you implement a load balancer, and then you break out one service. So you still have most of the traffic routing to your monolith app, and then there's one service. And then you break out another service, and you break out another service until eventually everything is microservices. One example is there's a phenomenal talk from my company. One of my colleagues, Jeff Plum, he did a talk at KubeCon this year on GitLab's cloud native transformation. And there was a decision made about whether to break each service into its own container or actually to have what we call a sidecar pattern where there are multiple parts of the app in a container, and we actually decided to go with that. So I'm happy to chat through some of the more bits and bytes and the details, but I would say the high-level best practice is breaking it in small pieces and making that gradual transformation. Yeah, that's a good question.
So if you use commercial clouds like Amazon
And
you'll be able to deploy the same.
sorry, if we can just get the question again with the microphone.
So if we use commercial web services like Amazon, AWS, or Azure, can you still just get them to configure this container and microservices architecture?
Yeah, that's a phenomenal question. If I'm using a cloud platform, AWS, Azure, GCP, IBM, et cetera, what does it look like to use containers on those platforms? The answer is the story can be complex, especially on AWS. There are 5 or 6 or 17 different ways to deploy containers on AWS. What I've seen successful is when folks are first starting out, they will tend to use a Kubernetes managed service. So you can think of managed services go along great with microservices. Some of the services are internal, your teams develop them. Some of them you're consuming from a cloud provider. So this might be your database. You might use RDS from Amazon, or you might use Amazon Lambda to get some serverless functionality. So these kind of managed services go really well in a microservices architecture. And one of these managed services will be a Kubernetes managed service. All of the major cloud providers offer them. Google Kubernetes engine, Amazon Kubernetes, Azure has a Kubernetes engine. And so that abstracts away some of the complexity. It means you don't need to manage and update that infrastructure. You're just consuming that Kubernetes. And there are tools, not just like GitLab, but tooling that will allow you to containerize your applications, store those containers in a registry, and then deploy those onto a Kubernetes managed service. And all of that tooling works together. So there's many ways to do it. I've seen folks roll their own. I've seen folks be able to spin up and test quickly with those managed services, and it's something I probably recommend.
Hi. So right now I have a hybrid ecosystem. So we started moving pretty heavily into cloud probably about 2 years ago. And what we're finding is it's not less expensive. It is really some cost avoidance. So what you can, all the capabilities you talked about with cloud infrastructure and environments really support the requirements for continued velocity, increases in velocity and scale. What we're struggling a little bit with from an investment perspective is taking the enterprise there as a shift. If I wanted to do those things on-prem, I couldn't do it at cost that I can get in cloud. But cloud isn't any cheaper, it's just a different place to do it. And then I'm also getting hit with operational expense versus capitalizable expense. So I'm just wondering, is there a financial model that you're using or you've come across that helps when companies need to make this kind of transformation, especially because of all the capabilities that are unlocked?
Yeah, no, that is a phenomenal question, spot on. I will ask, today, are you pre-provisioning your hardware or using like a container orchestration like Kubernetes? Are you, which one? Both. Both, okay. Oh, okay.
So again, we are still transitioning. We are heavily transitioning towards Kubernetes.
Oh, okay, awesome. Yeah, I think you're spot on. Migrating to the cloud, a huge challenge is the OpEx cost model. And the challenge, of course, is when everything's in your data center, it can feel much more controlled and predictable. And then you move to the cloud, somebody can ship out a bug, and all of a sudden your usage spikes, and it can take costs off the rails. So there are those risks involved. It definitely involves usually folks managing those costs, especially on something like Amazon. The costs can be very complex. So this is where I'm hearing from folks when they move to container orchestration, and especially if they're doing something like auto scaling of their nodes, that definitely helps to control costs, but it does not necessarily help in that model where the cost can go off the rails and all of a sudden you're trying to manage as OpEx or predict it, and it can go infinitely high. So I would say generalized, I'm seeing hybrid patterns. One that I can think of is one of our customers is using their own data center. They kind of have this challenge where everybody wants to ship their code at 4 o'clock on a Thursday because sprint demos are on Friday. And so throughout the week, there's not a lot of load, but all of a sudden 4 o'clock on Thursday hits and their data center gets slammed. So most of the time, they're running those workloads in an on-prem data center, but they're able to burst out to the cloud during that time frame. So I have seen that type of hybrid model help to control some of those costs. And in my experience, I haven't seen an easy answer there. It is a risk. It is something that is complicated. I've seen dedicated personnel simply owning cloud cost optimization. And that's a challenge. And I'd love in the networking to hear more about what you're doing and how you attack it. That's a great question.
Yeah, I mean, during deployment, there should be monitoring by infrastructure, right? And basically a reversion to the original set of containers if, the new set of containers runs off the rails, right? That's the beauty of it. You don't have to do a full blue-green like you did with VMs. You can kind of ooze containers back and forth until you're sure. It was pretty hairy when you had to do blue-green, right? Because you'd probably leave it running maybe for 20 minutes, both the blue and the green at the same time, just to see if the perf blew up, and then you commit to the new, to the new version. But you don't have that pain with containers if you get pretty slick with managing them.
Yeah, I'm really glad you made that point. I didn't talk about it in the talk, but the value of monitoring and observability is tantamount and crucial in this space. Again, when everything is broken up tiny parts, those reversions become a lot easier than these big ones. We're just about on time to network, or we have a few more questions?
One last one.
Since we're talking about people today in digital transformation, William, can you talk to some of the cultural attributes of cloud-native development teams and perhaps how they differ from previous methodologies and operating models and things like that?
Yeah, that's a phenomenal question. I tend to see Agile as a process enhancement, cloud native heavier on a technology or architecture enhancement, and DevOps as both technology and culture. And so really cloud native, a component of it is DevOps. Essentially cloud native is DevOps, CI/CD, containers, and microservices. So that cultural component is very heavy in adopting those in the teams. I would say that the idea of owning the pager, this is one where I've seen where you break out into microservices in an older world style, in a pre-DevOps world, you would have one organization is writing the code and they ship it over the fence and somebody else is responsible for keeping it up. And that type of cultural breeds animosity. It makes it very difficult. This organization is rewarded for moving innovation forward, and this organization is essentially, they're rewarded on reliability, so they're incentivized to actually slow innovation. So those two cultures don't necessarily mishmash. I've seen this in several ways broken up, where folks can be on a cross-functional team, where that cross-functional team ships and then operates the software. And I've also seen it as, like where I showed on the slide, where they own different parts of it. But that ownership of the operation of the service is a cultural component that says, when this thing goes down, I'm going to get paged for it. I have an ownership of it. I'm going to, frankly, ship higher quality code. I heard a story recently that there was, in the car warranty manufacturing line, when they took the folks that were responsible for engineering the car and then said, okay, in 3 years, you're going to be responsible for warranties. Well, they really changed how they designed the car, and they avoided things like, for example, making it so that you had to take out the entire engine if you wanted to replace a headlight, because they knew I'm going to have to deal with that problem down the road. And so culturally, the culture of ownership, where you're not siloing out your teams by function, but they're able to work cross-functionally, that type of cultural enhancement comes part and parcel with DevOps and cloud native.